In this video, we're going to look at using energy and homeostasis and transport of materials. So let's look at homeostasis first. And remember, homeostasis means keeping conditions the same. And there's a few things that we got to keep the same. We got pH and temperature, and those really need to be constant because of enzymes. Remember, pH and temperature can affect the rate of enzymes, and if they're too extreme, can denature enzymes, and that's why you die. We also need to keep water and ion concentrations. That's like salts and things like that. That needs to be kept constant. And glucose. So remember things like insulin. And when you can't maintain that homeostasis, that's kind of when things like diabetes happen. Now, hopefully you guys remember this video about buffers and how the buffers were used to keep pH from changing too fast. So if you remember in the video, we put like 2 drops of acid in this solution, and it went all the way down to basically pH of 0. And in the buffered solution, it took something like 80 drops to get it down to that same pH. And so buffers are just one of those ways that your body helps maintain pH and maintain a homeostasis. So let's look at the transport of materials. And there are 2 types of transport, remember. We got passive and active. And the main difference is passive doesn't use energy. It goes with the concentration gradient. And we're talking about osmosis and diffusion. And now with active, I do use energy in the form of ATP. Remember, easiest way to remember that, active transport, ATP. It goes against the concentration gradient. And we're talking about things like muscle contractions, neurons firing, that kind of stuff. Alright, so remember, this is a gradient. Another name for gradient is a slope. And in this case, I'm going from high elevation to low elevation. And if I have a car and it's on top of a hill and it rolls down the hill, that's like passive transport. I did not have to add any energy to that situation. It just happened on its own. So that's called going with the gradient. Now if I flip that around though, and I put the car up the hill, well, that requires a lot of energy. And so that's going to be active transport. And in these kind of situations, that's going to be the same way. If I'm going from a high concentration gradient to a low, that's passive, and vice versa is active. So when we look at that, here I have my high concentration. I got a lot of solute on this side, low concentration on this side. So if molecules move from high to low, that would be passive. It doesn't require any energy. But to pack more molecules into that high concentration area, to pump them across, that requires energy, and that would be active transport. Alright, so let's look at the processes of osmosis and diffusion, which remember are both passive transport. Neither of these requires any energy. So in osmosis, remember, this is talking about the movement of water across a semi-permeable membrane, and in this case, we're saying the plasma membrane is that semi-permeable membrane because it's selectively permeable. It lets certain things in and out. In this case, we're going to say it allows the water to pass, but the solute, things like salt, sugar, that kind of thing, too big, and so they can't pass across the membrane. So remember, in osmosis, only the water moves. The solute doesn't move. So let's say we have a situation in which we have a cell, it's in a water solution, and it's a very high concentration outside and a fairly low concentration inside. And I always like to think that water goes to the higher number of solute. So in this case, the water is going to move out because there's more solute out. And if water moves out, then the cell is going to shrink. So really all you got to do is figure out where is there more salt, and then that's where the water is going to move, and then the cell's either going to shrink or swell or stay the same. So let's look at 3 scenarios. In all 3 of these beakers, I have a 25% solute solution. In the first cell, I have 10%, and then 25%, and then 50%. So the first thing is, where is there more salt? Well, there's more salt outside, they're the same, and then there's more salt inside. So if the water moves to the higher number, water is going to move out, in and out at the same rate, and in, and that's going to result in the cells shrinking, staying the same or being at equilibrium, and swelling. So again, find them where there's more salt, that's which way the water moves, and then the cell is going to react. All right, so let's look at diffusion. And here I have a very high concentration in the corner. And remember, diffusion is just the spreading out of molecules across the space. So there we go. The molecules are now spread out and they have reached equilibrium within the space. Remember, this is very similar to if I spray perfume in one corner, eventually it's going to spread out and everybody will be able to smell it. And I don't have to add any energy to do that. Again, this is passive transport. And now, diffusion can also occur across a membrane. So remember, in this case though, the molecules can actually pass through the membrane. So in this case, I have a high concentration over here, low concentration over here. So again, passive moves from high to low. Molecules are going to move across the membrane in this direction, and they're going to spread out until they're equal concentrations on both sides. Main thing to remember, if the water's moving, that's osmosis. If the solute's moving, that's diffusion. And that is the process of passive transport, transport of materials, and homeostasis.